Let's look at our first two C programs designed specifically for the Nu32. This is Simplepic C that's inside of my folder Simple that contains my make file, my helper C and H files, and then because I've already compiled it, all the outputs from the compilation process. Now the make file is something we changed when we made the skeleton. We added the paths to the compiler, the location for the Nu32 utility, the port number for my board, and the location of putty. The rest of it we don't have to ever change. And in fact, we never have to enter these things again unless we get a new board or change the location of one of these programs, because it's saved in skeleton, and every time we need a new program or project, we're just going to copy skeleton, which takes this original version, and the only thing we have to change is our C file that contains our main function. So here is Simplepic.c. We'll review it line by line. We don't know what a lot of these variables are yet, but that's what we'll be doing for the next few weeks. So the first thing on top of our code is a #include xc.h. So this is a helper file that contains all of the variables we're about to see, and basically allows us to manipulate the physical world by using the pick. And we'll eventually find where that's located on our computer and dig through it. It's a nice, this one include adds thousands and thousands of lines to our code. But of course, in the end, in the linking stage, only the ones that are necessary are included in our executable. Okay, this program, what does it do? It flashes the lights, and if we push the user button, it pauses the flashing of the lights. So all that kind of pausing will be done with a function called delay. And delay is like a fixed amount of delay, so it doesn't take anything as an input and it doesn't return anything. So it's a function that's just going to eat up some time. Here's our main program, and we see a few things about main. It ends in return 0, kind of like a C on your computer, but that's after a while one statement, and a while one never ends. So on our microcontroller, our code is going to never end until we remove power or turn off or reset the pick. And as soon as we give the pick power, it's going to come back to the top of main and begin again. So it's unlike our computer that we have to tell a program to run, and when it's done, it stops. As long as the pick has power and something in its memory, it's going to run it. Okay, so that means that before we hit the while one, we're going to initialize some aspects of our code, some variables. And then when while one occurs, our functions are going to happen. So in this case, we need to tell some of the pins to turn on to control the LEDs that are pre-soldered onto our board. So that's what this line of code does, and we'll review that in more detail soon. And then these two lines tell which pins are on and off. So you see from a 0, that probably means that that pin is off, and this 1 means that that pin is on. But in this case, a 0 actually turns the LED on, so a low voltage is turning the LED on, and a high voltage is turning it off. We'll review why that is at some point. Then we get to our while one. So we turned on our pins. One is on, one is like lit, and one is not lit. We delay, and then we call this invert. It's not exactly a function, but it acts like a function. And we specifically invert those pins so that whichever one was off is now on, and whichever one was on is now off. And as soon as that happens, we then delay a certain amount of time, and then we invert, and we just do that forever. So let's look at the delay function. The delay function has for loop, so starting at 0 and going to 1,000,000, adding 1 each time. We will check to see, is the button pushed? So the user button is on this pin. And if the user button is pushed, we will go inside of this while loop and we'll just sit here. We won't do anything, so that means the LEDs will not blink. And we'll just keep reading that pin to see, is it pushed? And if it is pushed, we'll just sit here forever. As soon as we're not pushed, we will continue our counting to 1,000,000, and then the LEDs will flip, and then we'll count to 1,000,000, and then the LEDs will flip, and so on. And the interesting kind of questions that we'll be able to answer after reviewing the rest of this course is, how long did this function take? Like when we said count to 1,000,000, and we know that the pick is running at 80 megahertz, is this 1/8 of a second? Is this 1/80th of a second? If we double this, would this code take twice as long to run? how exactly do we make LEDs flip and turn on and off? So that's what we will be going through the rest of the class. Let's go look at Talking Pic, which is slightly different. So in Simplepic, we were manipulating variables from xc.h that didn't have very readable names. Here in TalkingPic.c, the first thing we're going to include is Nu32.h. So this is a set of helper functions specifically designed for our Nu32 board. And now we'll have some functions of our own to do things. So we will eventually dig through Nu32.h and C to see how they work. Okay, the Talking Pic program says that the pic will wait until it receives text from PuTTY or screen, and it will save all that information until it receives the enter key, and then it will print that data back, and then it will repeat, and each time it does it, it will flip which LED is on and off. Okay, so we're going to have a character array called message that stores those letters up to 200. So if you did type in more than 200 letters before hitting enter, it would probably start overwriting from the beginning. Then we're going to call this function Nu32 Startup. So the microcontroller has to be told some settings, like which pins have the LEDs in the button, but also how fast it should be running. So the Nu32 Startup is initializing all those standard events, and we'll call that in our code from now on. Now we get to the infinite while loop. We call Nu32.read UART3. So this says read from the UART, how the computer is talking to us, save whatever gets typed into message. This is what we call a blocking function. It'll stay here forever until it sees a /n character. That's what gets sent from screen or PuTTY when you hit the enter key. Okay, as soon as it gets the enter key, it will write that message back. It will also enter a /r/n so that in PuTTY or screen, the cursor moves down one line. And then it flips the LEDs. This is another way of changing the LEDs. Now the name of the LED is a variable rather than referring to the LED itself.